Hey developers, welcome back to this new video, and this video is about queue data structure. We're gonna implement the complete implementation of queue, and it is similar to stack. So let's get started. First of all, what is queue data structure? So what we see in real world is that the meaning. So as you can see in picture, the people are waiting for the tickets, like in a movie theater, or we are waiting for a call in call center while calling through the call center. So it's based on queue. So queue means first come first serve, which can also be called as first in first out data structure. So first goes, like the first data we put in is the first data we remove from the queue. So we can also say something like we can insert element at the last of the queue and remove element from the beginning of the queue. That's what it means. So it is very useful in many real world applications. So let's get started the implementation of queue using Python. So here we gonna implement the queue data structure using Python. So I comment out these things here. You can see the queue class to be created, and these are the methods in the queue. So basically, for inserting, we called it as enqueue, which is adding an element to the queue, which is appending to the end of the queue, and removing from the beginning of the queue will be called as dequeue. And front means we gonna peek the front element, which means without removing it we are seeing what's in front. And a rear element, which is the end of the end element, that we can see. And length and string representation of a queue, so that we can easily print it and visualize it. So let's start it. So first we need a queue class. So let me create it, and you can see the syntax. It goes like that. And we need init method, as we do in all many videos. Yes, we need self, and we need no any parameters inside when instantiating a queue. So self dot. So in this video, for the queue we gonna use a Python list as a base for creating a queue. So for creating a queue, or for creating a stack, we need an initial data structure like a array or a Python list maybe, or can we you can use linked list too. So we, in this video we use Python list as the base for this structure. And we need size, right? So let me add the size attribute here, so that it is maintainable, and we can produce the length in constant time. And so we are up to second method, which is enqueue, which is adding an element to the queue at the last. So it requires data parameter, and we pass on an argument. So it must be added to the queue. So self.queue dot append. We can use the append method because it's a initial data structure called Python list. In Python list we add elements through the append method, so we can follow that. So we want to append the data here, and then the dequeue method. So we have to maintain the size, so I increment it by 1 here because we are adding an element to it. And now the dequeue method will remove the element from the beginning of the list, beginning of the queue. So it requires no parameter because we are just removing the first element by default. So self dot q dot pop will remove the first element. Sorry, pop of index 0 will remove the first element, and we can decrement the size by 1 so that the size is maintainable here too. And yeah, and front will peek the front element, that first element, so we just returning the initial element. So front will do that, so we have to return the front element self dot q. Oh, sorry about that. Yes, this will this will return the front element, that first element, and rear we want to return the last element. So as you can see here, write the code. It goes like that, like negative indexing to get the last element, and in order to get the length we use dunder len method. You can see my stack video or linked list video to for the use of dunder len method. And here we return the size of the queue, self dot size. So it will return the size, and we need the string representation, right? So we can do something like this. Like we need the string representation, so we create a variable like result and give it a string. So let me fill up the base case, which is if the queue is empty we must return queue is empty. So if self dot size equal to 0, then we must return something like queue is empty. And if that's not the case, we must return the elements. So we create a loop for that. Let's create a while loop, and or we can also create the for loop because we know the length. So for I in range self dot size, we know the size, so iterate through the queue, and we are returning we are concatenating the elements to this result, and we are returning this result as the end. So it goes like this, like we want to return the stirrer of I because it's a string representation, and we want to add it to the like concatenating it to the result like this, and we add one more element like one more string like an arrow, so that it's usable. I mean, the arrow goes like this because it's a queue, so you can see at the last why I put this arrow. Whereas in stack we use stack or linked list, we use the opposite arrow. And now we can return the result. Yeah, okay, let's create a queue. So I name it a line maybe. Okay, we can create a queue like this, queue object like this, like giving a parenthesis. We require no any argument to that, and we are adding like enqueuing some data into it, like 30. So I enqueued these three datas, and we can print it here. So we can use this print because we used the dunder init method, I mean a dunder stir method, so we can use the print like this. So let me do some DQs over here. Yeah, it requires no any argument, and let me print it again. So the first data will gone, and we can print the line again, and now we can do the DQ again. We can print it again. Yeah, okay, let's check whether it's running or not. Yes, it's running. So there is a mistake. It is showing like a 0 1 2. So it's because here we are appending the I to it, whereas I is something like the index of the elements inside it. So we have to produce the values rather instead of index. So let me do it here like this. So it will produce the value instead of index. So let me run it again. Yeah, it goes like that. Yeah, it produce first we are adding 30 to it, and 69 and 33, and we are removing 30 from it. So because queue works like that, we can only remove from front, and we are removing again, and we are printing again, and finally the value is this. So let me print the length here in middle, so that we can check if the len works. Okay, len of line, it will work. Yeah, it's 3 here because we have 3 elements initially, so it works perfectly. So this is the queue data structure. So thanks for watching. If you have any doubts or any suggestions, you can let me know in comments. So thanks for watching. Bye.